In engineering, a truss is a system of interconnected beams which is used to make a relatively lightweight, strong, rigid structure. We live in Pittsburgh, so we see lots of truss bridges. And one of the things about trusses, when used in applications like bridges, is that they can often be treated two-dimensionally. You can see that both sides of this bridge follow the same exact pattern. You could almost flatten this into a 2D image and get your design that way. And trusses are often designed and analyzed in 2D. My Truss Generator / Analyzer program is meant to take the description of a two-dimensional truss and calculate what the forces experienced by its various beams would be. It is also meant to, simply given the input forces and supports for a truss, generate its own truss that could withstand those loads. In Analyze mode, you can select the components of an existing truss design and find out what forces are experienced. You can see what the given load inputs are. For example, this is a force of 2,000 newtons, and you can see what the loads experienced by the given beams are. A negative load indicates that this beam is experiencing tension, while the positive load indicates that this beam is experiencing compression. If the user does not specify what beams should be placed within a truss system, but only specifies the loads and supports, the program will automatically generate its own random truss system, which is solvable. In Optimize mode, the program will also try to improve on this truss system to make sure that all beams are loaded within an acceptable safety factor. One can step through the random mutation of optimization and see when items are retained or discarded, and one can also play this at high speed. With the current algorithm, equilibrium is typically reached at a point where the design would not normally be acceptable. However, this is simply a work in progress, and one can see that we have in fact reached an acceptable score in the second category of scoring, meaning that all of these beams are within the pre-designated factor of safety for these loads. None of these beams would be dangerously loaded in this configuration. The hope is that with further improvement of the generation and scoring algorithm, even better truss systems could be automatically generated.